Hey, welcome back. We're going to do part 2 of 6.1, which is on slope fields. And I know you guys have seen slope fields before, but we really haven't talked about them very much. And a slope field it looks like a whole bunch of little lines on a graph. Essentially what it is it's all of the possible slopes from a differential equation shown on a two-dimensional graph, an XY coordinate plane. And it sounds worse than it actually is. So let's start by making one. So I've got an example here. I've got y prime is 2x plus y. And what that says is we've got y prime being the slope, the derivative. So our slope comes from 2 times the x value plus the y value. And some of the differential equations can be a lot more complicated. Some can be simpler. Basically, they're all just going to have x and y values that you're going to plug in to come up with the slope. And that's kind of what we're going to do together. So if you guys need to, take a minute to draw a coordinate grid here, and we're going to kind of draw one together. Okay, so the way you draw one is you kind of just make a table of values, whether you do it in your head or whether you do it, writing it down. So I'm going to write one down, and I'm going to pick an x and a y value, and then from those two values I'm going to come up with my slope. And traditionally you pick the easiest ones that you can, just to find the answers quicker. So I'm going to start with 0, 0. So 0, 0, I would have 2 times 0 plus 0, which would give me an answer of 0. So at 0, 0, I'm going to draw a little line with a slope of 0. And then you keep doing that for, traditionally you pick integer values. If you wanted a really accurate slope field, you could pick quarter points, half points, whatever you want, but we're just going to go with integer values. So I'll go with 1, 1 next. So 1, 1. 2 times 1 would be 2, plus 1 would be 3. So my slope at the point 1, 1 would be 3, which is kind of a decently steep line. And let's pick negative 1, negative 1. So negative 1, negative 1. I would have 2 times negative 1, which would be negative 2, plus negative 1 would be negative 3. Okay, so at negative 1, negative 1, I need to draw a slope of negative 3. That's pretty close. And essentially, you just kind of fill out all of the spots with slopes. So we'll do a couple more, and then what I'd like you guys to do is kind of pause the video and try to draw the rest of it yourself. So let's pick negative 1, 0. Sure. Negative 1, 0. I'd have 2 times negative 1 plus 0, which would give me an answer of negative 2. So I got to draw it a little bit flatter than negative 3. Right about that. And then why don't I just go directly above that? Whatever points you pick works. So a lot of times it works better to kind of pick them orderly. I know some of you guys like to pick them randomly. Go for it. So let's go with negative 1, 1. Negative 1, 1. So this would be 2 times negative 1, which would be negative 2, plus 1 would give me an answer of negative 1. So I have a slope of negative 1 right there. And if you can figure out patterns, I had negative 3 right here, negative 2 right here, negative 1 right here. The pattern above would probably be a slope of 0. Above that would be a slope of 1. And you can use patterns that can help you go a little bit quicker. So pause the video, take a minute, draw the rest of it yourself. And if you got it drawn out, this is what it should look like. Now we only did -3 to 3, so that's kind of, the middle part of this graph. This one shows -5 to 5. But it's just basically a big graph of a lot of little slope lines. Now each one of these kind of is a separate particular solution, to be honest. So this is, I know we didn't really talk about this before. It is just a big graph of a lot of slopes of the differential equation. But if I wanted to, I could actually find all of the individual general solutions put together here. So let me pick a random point. Like, sure, let's go with the point 2,3. Now, if I wanted to, I could draw the particular solution that goes through the point 2,3. And then the way I would do that is just kind of follow these slopes. Like right here, I can tell it's going upwards. And if I kind of keep following it down, it's going downwards. And then farther down I go, I can tell that my slopes kind of start to change. And as I get a little bit farther over, then all of a sudden they flatten out because I can see these slopes of 0 going right there. So right about here, I got a slope of 0. And then it's going to start following upwards. And you just follow the lines with it. And then this would be a drawing of a particular solution that went through the point 2,3. And if I integrate y prime equals 2x plus y, I would get the general solution. This slope field is a picture of all of the general solutions together. And then I drew one particular solution that went through the point 2,3. And there's some various uses for these slope fields. I mean, for right now, we're just kind of going over how to draw them and how to come up with answers from them. Okay, the last type of question that you'll get on slope fields is being able to match up differential equations to their particular slope fields. And you could theoretically just take the time and draw the entire slope field from each one of these differential equations, but that would take you forever. So most commonly what you're going to do is you're going to kind of look at the slope fields and try to identify a location that has different values. Like say if I look at the point 0, 0 in all of these, well, they all have a slope of 0. And that wouldn't help me identify which one's which. Because if I plug 0, 0 into each one of these three, well, they're all the same answer. So I look for spots that are different. And if I'm finding any, it looks like I'm going to just pick, let's just look at 1, 1. What do we have for 1, 1? This one has a slope of about 1. This one has a slope of about 2. This one has a slope of about 1. So I'm probably not going to pick 1, 1 because they're not that different from each other. Looks like right here I see I have a slope of 0. I have a slope of -1. And I have a slope of +1. So I'm going to pick the point 1, -1, and I'm going to use that point to figure out which graph goes to which differential equation. Okay, so 1, -1. If I plug in 1 plus -1, I should get an answer of 0. And the middle graph had a slope of 0 at 1, -1. And then that tells me this differential equation is y prime equal to x plus y. Okay, so next one. So y prime equals x. There is no y value in this one, so I'm not going to plug in the y value. So I've got y prime equals 1 plus, there's nothing else. So a slope of 1 is the final answer. And looks like the graph on the left matches up with that. So right here I've got a slope of 1. So this one is y prime equals x. And then, you don't necessarily even have to finish the last one because you'll know exactly which one it is, but if you want, you can. So if I plug in the point 1, -1, I'm only going to plug in -1, and this has a slope of -1. So this would be y prime equals y. And that's traditionally the way that you're going to do it the fastest, is you try to identify locations that are different. And if it's a case of, only two of them are different, well, that's fine. You can at least pick that one spot and figure out which one of the two is which and kind of eliminate things as you go along. It's kind of just all about using your logical thinking to eliminate choices. All right, well, that's it for slope fields.